So good evening, everyone. Welcome to our second class for Python, introduction to Python for data analysis, basically Python programming language. So yesterday in our class we went over a programming language. We discussed a few things. So I'm going to try and get the video done for today's and probably have it by tonight by God's grace. So what we basically did in the class yesterday, we went through Python. Sorry, where we started from was understanding the concepts behind language, why we need language, the essence of language, which is basically for communication, to communicate between two separate entities, right? So we moved on from there to why we need programming languages, which is basically to communicate between a computer and a human. Not necessarily okay, well, the way humans have languages to communicate with each other, that's how computers also have languages to communicate with each other. But what we are really concerned with is how we as humans can communicate with the computer, which is true programming language. So we have several languages, just like we have several languages in the human language, from English to Yoruba to French to Spanish to Portuguese and the likes. That's how we also have languages with computers, with machines. So we call them programming languages. So there's Python, there's R, there's Ruby, there's JavaScript, there's Java, there's C, there's C++, and so many more. There's Swift, there's Julia, I'm just remembering some interesting languages I've heard about. So I think recently, say I heard about one that was released recently, and there was hype around it. So that's going to take stop. Maybe it's going to take some programming languages away. So so basically, there's just like we have. I was saying, just like we have languages to communicate between each other for humans, we also have programming languages to communicate from with human and the machine, the computer. Well, it's a machine anyways that understands just zeros and ones. So so basically that's the essence of a programming language, to communicate between human and the machine. So now to do that we have to learn the language, which is more of like you're trying to learn Spanish, you're trying to learn Chinese, you're trying to learn French, you're trying to learn a new language. So basically, that's what we are going to be doing. And I mentioned that we are going to be starting from the very first steps, like the ABC of English language. So we are going to be going to the ABC of programming of Python programming language to be specific. To be specific, there are other programming languages, right? But the one we are dealing with is Python, because Python have, yes, there's R. I mentioned I already gave the difference or why we are going to be going with Python, right? And so Python is for me very easy. I'm not saying R is not easy, but it's very easy. It has a very wide community and a lot of support. And you can decide to go into other things with Python. There are normally there are programming languages that are meant for specific things. No, not like they are meant for specific things, right? But it's easier to do those things with them. For instance, if you are going to be writing, sorry, if you are going to be building web applications, your websites, your yeah, basically websites, you're going to be using a different programming language. If you're going to be building mobile applications, I mean your applications on your phone, Facebook app, WhatsApp application. For Android, there's another programming language. If you're going to be doing it that same thing for iOS, you need a different programming language. I think, though I think there are languages now that can write both Android and iOS, right? If you need to build games on your system, your mobile, like I mean your computer, there's a whole different language you need to learn. So like there are different for Python, for data analysis, there's a different language. For AI, machine learning, artificial intelligence, there's a whole another different languages. There are even some other things I would even know of, like I can't think of right now, that there are other languages that are actually meant for it. For instance, there are some specific work that you don't just use your normal Python. There are some languages that they actually use for those work, right? So, um, let me leave that about that. So we are going to be starting with the very basics, right? And we'll be using our Jupyter. I'll be using Jupyter Notebook today. I can switch. I can use uh Jupyter Notebook. So I mentioned the reason why I'm using Anaconda is because Anaconda has everything we are going to be needing. So Anaconda has Jupyter Notebook and it has the other things that we'll be needing easily. You don't need to install them. So it's like an all-in-one package. You find out that the size is even very large, about 800 MB, about 500 to 800 MB, right? So that's what we are going to be doing. So for me, I have Jupyter installed. So all I need to just do is run it. So you probably have something like this similar, something like this tab. You probably see something like this terminal. So I call it is called terminal, right? You so probably have something like this that comes up on your screen. So I think if you want to start up your own and with Anaconda, you can. There are two ways actually. Tito, in case you have your step up, you can just let me know. Um, there are there are two ways to start your Anaconda, but the oh okay, can you share your screen? Oh, like is it connected to the internet? Like, are you connected to this call, or can you connect to the call with your laptop? Uh,
Yeah, I'm connected to the call, my laptop.
oh, okay, cool. Okay, cool. So you can share your screen. So we use yours to just navigate around opening Jupyter Notebook. I think I should stop sharing that case.
Hmm. Mhm.
Okay, why the screen is coming up or why you're trying to set it up. So just to chip in some of these things, so along the line, I think we should have maybe a section because we are going to do projects. We're going to do a final projects, and um, I want to do it in a way that it will be something tangible that you can add to your resume. Because I also want every one of us to have. I know some of us are doing different things, right? But I want us to have a resume like that we can use to apply to all these tech jobs, like data analyst roles that will be coming our way. For some of us that are not working in as data analysts that want to work as a data analyst. So probably like we also need to optimize our LinkedIn on some things and some little tips. I think I don't know. Maybe was it this call? I think it was a particular class that we had that was talking about. Okay, I think it was last class. I was talking about LinkedIn and optimize, not really optimizing, but it's more of like job search, how you can go about it. I think I mentioned, yeah, I think it was last class. Mm-hmm. Yeah, here we go. Awesome. Okay, so here is what a Jupyter, sorry, Anaconda looks like. You can see we have, interesting. We now have Anaconda notebooks. So we have a lot of things here, but we are only interested in, let's say, two things or maybe one. So you can see that some of these things have launch behind, be like below them. some of these applications, they have launch, the launch button. So it means that they are already installed. So if you scroll down, well, okay, can you scroll down? So, I think there should be VS Code and oh, I didn't see VS Code. Okay, there's PyCharm here. Okay, you need to install PyCharm. Okay, PyCharm is also an IDE. We'll not really be going to that. Like I said, what we need is right up there. Jupyter Notebook. I think we all saw it. So what we need exactly is the Jupyter Notebook. Although there's Jupyter Lab, but the lab and the notebook, they have, it's more of like this notebook in a closed environment. So but we are just going to be using the Jupyter Notebook. Is That's all we need. It is very easy that way. So if you click launch, can you click launch? No, for the Jupyter Notebook, not Anaconda Notebooks. Anaconda Notebooks is a cloud package, and I think it's paid actually. I think you have to subscribe for it. So we are going to be using Jupyter Notebook instead, not the Anaconda Notebooks. The Anaconda Notebook is a paid. Well, I think it's cloud. I know it's cloud, so I'm assuming that it is paid because cloud is you okay. There are a few cloud platforms that you can use for free, maybe not really much. So that kind of thing. So by now your Jupyter Notebook should have launched, although you are only sharing the Anaconda screen. So we are not able to see what it looks like. Yeah, there's even spider, but I think we just stick with Jupyter for now, at least. Tito, as he opened up,
I've opened it. I don't know why it's not showing.
that's because you are oh, are you seeing it?
Yes.
Okay, that's because you didn't share your whole screen, you shared just
Oh.
the Anaconda screen, just an application. So
Okay, so I should stop sharing and share my.
yes, I don't know if you can stop sharing. So when you stop sharing and you want to start to share, I think you should have like three tabs.
Yes.
So yeah, exactly. So you pick the last one, that's the entire screen.
Okay.
Okay, so while it's coming up, we are almost there. So what's one of the things we are going to be doing, like I said, is the ABC or programming languages of basically Python, right? So we are going to be um it is called data structures, but I call it basic data structures because they are advanced data structure, right? And so what I'll be starting with is because I'll try to make it relatable to something we can relate with. That's what I mentioned. So in Python, there's something we call lists. So I think I'll just okay. Let's wait for Tito to share our screen. Uh,
There's an error telling me I can't share my screen.
uh, uh, okay, don't worry then. Let me just share my screen back. Since normally if you go through that process, it will open up Anaconda for you and you can continue. So I'll just share my screen. So this is my screen, this is my browser. So what I'm going to do is, like I said, this is what your stuff should look like. So you can just probably create a folder and name it, or probably go to your notebook, oh sorry, maybe desktop or documents. I like to use documents. Then I'll create a new folder. Create this folder, untitled folder. So I want to rename this actually. Come on, I think they should be able to rename it here. Titled folder. Uh, okay. I'm not saying to rename. Anyways, you can rename it later. So what I actually want to do is create a new notebook. So Python. So we're going to put a new file inside the directory. So here we go. I don't know why this is slow. So can you see my screen? Okay. So this is what. Okay, awesome. So this is what a Jupyter will have showed us before. This is what a Jupyter notebook looks like. So this is where we are going to be writing all of our operations, right? From oh, sorry, I should share this tab instead. Okay, good. So this is what where we are going to be writing all of our operations. So you should have something like this. So what we are going to be starting with is should I walk us around this? So there's lists, there's something that are called the data structures in Python. So I'll change this to Markdown so I can write. So I'm going to write just like notes. So we have data structures, data structures in Python, and they are called lists. We have, okay, let me be very simple. So there's lists, there's dictionary, there's, hold on, there's lists, there's dictionary, there's tuple, yeah, there's tuple, there's boolean, there's a list, there's dictionary, there's tuple, there's boolean. So I think we can stop. Okay, let's just deal with lists, dictionary, and tuple first. So these are like the basic data structures in Python. So in Python basically there's no, I don't intend for it to be like this. Let me put, think this will give it shape. So where I'm running this is rather than click this button, I just have to press shift enter. So shift enter will run it and move to the next line. So there's control enter. So these are the commands I'll be using frequently. So shift enter is to run this line and go to the next line. Control enter is to run that particular line. Then alt enter is to just create a new line. Don't run anything, just create a new line. Alt enter. So if I have 1 plus 1 here and I press shift enter, you see output 2. So the output is down here. So if I come back here and I press alt enter, you see it has run this again. So this is like number of times it's running. So if I come back here and use control enter will run it and still remain on the same place, right? Can see how it's counting. So basically that's the way this works. So that's like simple things that we should pay attention to. Right. So we also have what we call variables. So we are going to be starting with simple things as um variables. Let me start from there. So we call them variables. So sorry. Um was it in this class that I mentioned comments? So in comments, remember what the comment is from SQL, that you can write a comment, nothing will run, nothing is going to, if you have a comment, it's more of like you want to explain what you are doing. Your code is not going to run, your particular syntax will not be run on that thing. So if I run this now, comments is just comments. If I put 1 plus 1 under, it is that 1 plus 1 that will run. This comment will not run. And in Python we use hash. In SQL I think it is I think 2 dash, yes, 2 dash. So different languages have their different comment syntax. Some have the same comment syntax, it's like the same, but they all have comment. So the comment here is hash, right? Good. So we are going to be working with variables. So what is a variable? Let me start from there. So a variable is like um an a a place where we store something. Let me start from there. So for instance now, um the way I have, okay, let me use me for instance now. So My dad gave me 500 naira that I should hold it. If you if you are looking for that 500 naira, all you have to do is call me. If you call me, I'm going to come and I'll give you the 500 naira. In that case, I am the 500 naira, like I am holding the 500 naira with me. So that's how variables are. So variables are like um alphabet, or just basically like things where we can store something, right? So now what does it look like? So let's look at this. 1 plus 1. 1 plus 1 is what? 1 plus 1 can be stored. This result now, I can store it inside the variable called x. So let me use x. I think a lot of us hate x here. So let me use something like m, or yes, let me say m. So m is equals to 1 plus 1. So if I run this, I won't get an output. But mind you, anywhere I call m, what will come out? 2. Let me delete this once. So anywhere I call m, what will come out? 2. Because 1 m plus 1 plus 1 is has been assigned to 2. So in the process of using variables, we have what we call assignment operators. So we have operators. I'm still going to explain about that properly, but let's just pay attention to this. So we have 1 plus 1. 1 plus 1 equals to what? M. That means we are assigning this value. So you can assign any value. You can say what you want to do is just m equals to 1. So in this place, anywhere you call m, what will come out? 1. So I can say m is equals to 1 and y equals to what? 2. Now, anywhere I call m, what will come out? 1. Anywhere I call y, what will come out? 2. So you can see here I have 2. Now I can now decide that I want to say m plus y. What would this give us? Can anybody try? Anybody? So when you say m plus y, what would you get?
3.
Good. So we basically have 3. So what has basically happened here is that we have assigned 1 to 2. So it's more of like you are assigning. You are saying, for instance, oh, Botemi will no longer be called Botemi, or me as a person. Oh, good. That's a very good example. So when I was giving birth to, I think they named me 7 days later after they gave birth to me. So during the period when they have not named me my current name now, what will they calling me? Probably baby, omo, that kind of thing. Now at that point, I am being referred to as omo. So tabani sorry. So when they say baby, they are referring to me. That's the name that has been given to me at that point. Now, after the 7 days, they brought out a list of names and they felt like, okay, this is a name that they want to give to me. Now, it means that I am going to be identified as that name. So, anywhere they are trying to reach me, all they have to do is, if I'm among a crowd of 80, all you have to do is call my name and I will come out. So if in another situation, I've seen cases where people have changed names, right? So now in cases where they now change names, it means that they are no longer being identified as that former name. They are now being identified as a new name. So in my situation now, let's say I used to be Botemi. Now, then in something happened and they decided to change my name to Emmanuel, right? So I'm no longer being referred to as Botemi. So anywhere they call Botemi, I'm not going to answer. But anywhere they call Emmanuel, I'm going to come forward. So that's the way assignment variables work in Python. So there are list of things that we can actually assign variables to. For instance, your alphabet from A to Z, you can use that. Can you use numbers? No, you can't use numbers. You can only use alphabets. You can use alphabets, and when I mean A to Z, not A to Z, I mean it can comprise, it must be made up of that A to Z. So I can have MAT equals to 1 and YAM equals to this. So if I call maths plus yam, I'll still get 3. So I can assign anything to it, but it must be letters. And also Python is case sensitive. So case sensitive means that is sensitive to capital letters and small letters. So math is not the same. Small letter uh math is not the same thing as capital letter M80. So in this situation now, I already have maths here. Let me comment this. Now I already have maths here, right? If I decide to now do capital letter M here and call anything, I'm going to get an error. It says maths is not defined, so that I have not declared anything to M80. So it means that it's case sensitive. So if I want to do it rather, I'll just have to put something in front. So let's say M80 is equals to 4, right? So M80 here is now 4. Yam here is 2. 4 plus 2 is 6. So it is capital letter small capital letter M is 4. With capital letter M is 4. With small letter M is what? 1. So you can see there are two different things. So Python is actually case sensitive. So now what are I'm talking about the names of things that we can use, right? So we can use letters, anything letter, put small letters and capital letters. We can start now. What can we start? We can also use some symbols, and the only symbol I think we can use is underscore. I don't think I can use plus. Yes, I cannot use plus. The only symbol I can use to probably save a variable is underscore. So I can say underscore maths. So if I can call underscore maths here. You can see that. So I can use underscore. I can use letter. Now, if I'm going to use numbers, numbers is going to be in the middle. I cannot start with numbers. So for instance, now you can see underscore M280. So if I call that M280 now, sorry, hold on. So if I call M underscore M280, I'm getting what? 3, because M280 is now 1. So all the things that you can use, like I said, you can use A to Z, you can use small letter A to Z, you can use um 0 to 1, and you can use underscore. Now all of this you can use it, all of this is, or I think you should probably be like, let me start on this. So let me say all the things that you can use to start your variable, you can use to start it, the name of your variable. So for instance, if I'm going to say I want to name this thing, what I can use to start it must be one of these. But along the line, maybe in the middle, for instance, I have a very long variable like Matthew Henry commentary. This is long. This is a variable. Matthew Henry commentary, I can say is equals to 10, or is equals to 100. Sorry, this one is still there. I comment this. So Matthew Henry commentary is equals to 100. This is a very long variable. I can decide to put numbers in it. I can decide to put even, I think I can put shapes. Can I put this? No, I can put numbers. Yes, I can use numbers. I can say 4, 5, 6, whatever thing I want to put. I can put this. But can I put numbers in the beginning? No, I can't put numbers in the beginning. I'll have errors. I can't use numbers in the beginning. But I can use underscore and I can use alphabets. So you can see this has worked. So if I copy this and put it here, let's say plus, or let me just put it back here. You can see 102 because this is 100 and yam is 2. So you can basically assign anything, but it must be from what? A to Z, capital letter A to Z, A to small letter Z, and small an underscore to start a variable. But when you can use other numbers to probably as part of the name. So that's more about variables. So you can hold anything. Variables can hold anything. Numbers. So in Python we have data types. So I think we are supposed to start from there. So data types. How do I do it? Okay, let me come here. So data types. Sorry. Python data type. So we are supposed to actually start from there. So in Python data type, or let me convert this to notebook. sorry, um mark down. Did I use, oh, I use hash. So in Python data type we have, sorry, we have integers. I know we all know integers. We have, sorry, integers. We have floats. We have um we have integers, we have floats, we have strings. So in Python it is called strings, right? Strings. We have boolean. Yes, this is where boolean falls in. So we have integers, we have floats, we have strings, we have boolean. I think these are the basic data types, or basic data types that we have in Python. So an example of integers is like whole numbers, right? One, two, enter my press, so I have an error. We have two, we have five, basically just numbers. Then in floats are more of like decimal numbers, like 7.0, 5.3214, or 3.142. That's pi. Then strings is basically alphabets from capital letter A to small letter Z, basically. So like cats, bug, chicken. So these are all strings, and for strings they have to be in quotes. Sorry, a string has to be in quotes. So for Python you can use single quotes or double quotes. So I can decide to use double quotes instead of what, single quotes. Python sees it as strings. Then remember I said Python is case sensitive. So in Python we have, for the boolean it is capital letter TRUE and capital letter FASE. So not small letter true and false. It is capital letter T and capital letter F. Right? So integers are 1, 2, 3. Floats. Now with numbers you don't need to put quote around it. If you merely put a quote around it, it becomes a string. If you don't put a quote around numbers, it's just known as numbers. Right? So these are the Python data types that we have. Sorry, I don't want it, don't like it coming out that way, so I think I just do it the same way I did last one. Yeah, so you can see now integers is this, float is this, strings is this, boolean is this. I think I should rearrange. Sorry, what did I do now? Okay, let's just leave like this for now. I'll rearrange it. So so that's all about the Python data types, or the basics that you need to know. And yeah, so I think, where was I? So where I was talking about variables. So variables basically storing something. So you can store, what can you now store inside a variable? You can store integers, you can store floats, you can store strings, you can store boolean inside a variable. So yeah, I think I can hold on now. So do you have any question? Okay, so I'm going to take the as no question. So now moving on, I've talked about the Python data types. I've not talked about the structures yet, but I have to talk about variables, right? So we we have some things that we called operators. So we call them operators, and sorry, I'm supposed to be writing. So call them operators and operands. So we are going to be a bit of notes first. So operators and operands. So what are operators and operands? Just things you already know. For instance, now 1 plus 1 equals to 2. I don't advise you run this because this is an error. But 1 plus 3 equals to 4. We know that. Let me even comment it out. 1 plus 3 equals to 4, right? Now, in this situation, in our case, what is the operator? What is the operand? The operand here is, or let me start for the operator here is plus and equals to. So the operators are plus, equals to, let me put a comma, equals to subtraction, that's minus, sorry, minus divide, um which one, we have double dash, double divide, we have percentage sign. It's called another thing here, but let me just call it percentage sign. So I think these are the basic ones. These are the ones, yeah, basically. So these are all of our operators. Plus, equals to, minus. Would I call equals to an operator? Let me leave it out. So let's just stick with plus, minus, divide, double slash, and percentage sign. So these are, actually it's not called percentage sign, it is called modulus, but I'll explain that. Let's just call it percentage sign for now. So basically it means that with these operators you can perform operations, you can perform mathematical operation like 2 plus 2 is 4. 2 plus 2, in that situation the operator there is what? Plus. Now the operands are now the values that the operator is working on. So in the situation of 1 plus 3 equals to 4, what is the operand? The operand is 1 plus. In fact, let me include this. In this situation now, what is the operand? The operand here is 1 and 3. What is the operator? The operator here is 1. Sorry, plus. What are you trying to do? You are trying to perform an addition operation, right? So if I come down here to say 1 plus 3, 1 plus 3 is a mathematical operation, and I'll press Ctrl Enter. You see 4. Right? So this is the mathematical operation. So 1 and 3 is the operand, plus is the operator. So 1 plus 3 is what? 4. You can change it to minus. Eh? Let's go end in 15 minutes. When last did I get this notification? I think Google has started though. Okay, so no problem. I would create another one. I have to look into this. So 1 plus 3, sorry, is equals to 4. Then 1 minus 3 will be minus 2. Of course, this is mathematics, right? 1 divided by 3, we have, oh, I didn't even include star here. That was multiplication. So 1 divided by 3 is 0.333. You can see 1 times 3 is 3. Then the double divide, you can use it here. You see what will happen. So okay, well, let me use this opportunity to explain what is happening here. So what this does is it tries to divide without remainder. So for instance, now if I say 4 divided by 3 normally is 1.33333, right? If I use double, I only get the whole number. So 4 divided by 3, or 4, yes, they call it floor division. So it's the single division is just division. The double one is floor division. So it divides and gives you only the whole number. It doesn't give you the decimal behind it, if there's a decimal. So 4 divided by 3 is definitely not this. Is normally is 1.333. Let me say 10 divided by 3 will still give us this. Let me say 10 divided by 4. Okay, good. 10 divided by 4 is like 2.5. So if I use double this, if I use floor division, I'll have 2. So the 0.5 has gone. So I only have 2. That's the way this works. You might be wondering what is it used for, why is it need? We'll get to see that in a bit. Then we have the modulus, the percentage. I call it percentage, but it's actually called modulus. So the modulus sign, what it does is it checks let me see. It's similar to your um divide operation, the floor division, right? So um hold on. Oh no, sorry. Yeah, it's similar to your floor division, but this time around, what you get is the remainder of a particular division. So in the situation of 10 divided by 4, normally, right? Let me put a comment and so if I do 10 divided by 4, it means that I'm going to get 42.5. My goodness, sorry, hold on. I'm going to get 2.5. Now, what this means is that there's how many 4 in 2? How many 4 can you see in 10? 2, right? That's why when we do 10 modulo 10 slash slash 4, we have 2. The remainder of this is what? 2. So if I run this now, I'm going to get 2. So basically what this percentage does is that it gives you the remainder of a particular division. So when you divide the remainder, what you get, that is what it returns to you. So in a situation where I do 10 divide, so it's like divide it by 5 and give me the remainder. So if I say, and we call it 10 modulo 5. So 10 modulo 5 is 0 because 5 divided by 10 is 1, sorry, 2. 2 remainder 0. So let's do something else. So let's say 10 divided by 5. So I'm going to be using something I've not taught you yet. So that's print. So I'm printing this command. So print is in Python is like I want to see the output. Print the output for me. So 10 divided by 5. Then I'm going to do print 10, then double divide by 5. Now you can see the output here. So 10 divided by 5 is 2.0 normally. Normally, if you use this, you get output as a float. Now, if you use this, you get your output as integer. It will only give you the first one. Then if you use this, you get your output as also integer. It will give you the remainder. So now let's use something. This call we end now. So how do I okay, let me finish this. So let me use something different. So let's say 11. So you can see now we have 2.2. Now 5 divided by 11 is what? 2. Remainder what? 1. That's why we are getting 1 in the last place. We are getting double divide. We are getting 2 here, and we are getting just 2.2 here. So depending on the scenario, or what you want to do, you need to use either of this. So let me end the call now, and I'll send another link to the group so you can join with that one. I'm really sorry about this. I sincerely apologize. So let's leave the call and join the next one. Okay, I think we should just wait about 5 minutes for the rest to join us. Okay, I think let's continue. Um, okay, so let me go back to the screen. Sure. All right, so I was explaining the signs, the operators basically. So majorly what we are going to be starting with, because you are wondering, okay, what's going on here? We are going to be starting with the simple, like these are the simple things, like just mathematical operations, right? 1 plus 1, 2 plus 2, how does it work? So those are the simple things that you actually need to understand. Um, so doing this in Python, right, in a programming language is the basics to knowing how the language works. So so I've gone through the basic operators from plus, minus. Okay, I think I should actually write it in a way that will be more. So plus is, I should probably use markdown for this. So I'll just take this out, then create a new and convert it to markdown. So I'm doing this because I want to write, so I don't need to if I run this, it will just come out as normal text. So operators and operands. So operators, so let me take this out. So basically I'm just going to identify them. So addition is identified as plus. Subtraction is identified as minus. Um, Division is identified as divide. Then floor division is identified as double slash. Then modulus or modulo is identified as this. Then we have multiplication identified as star, right? So I think this is it. So this is more of like the basics, right? Then so we understand what operators is, what an operand basically is. Let me move the commas. Comma. Okay, good. So this is how to identify operators basically in Python. And I'm supposed to perform more, but I think it's pretty much simple knowing what everything else looks like. So if you have to try plus now, So I'm going to just duplicate this so we can run it on our own. Minus, then which one have I not do? Plus, minus, divide, multiplication. So multiplication, if I run all of this now, I'm going to get, for the first one is 16. The second one is minus 6. 11 times 5, 55. 11 divided by 5, 2.2. 11 divided by 5, like using the floor division sign, is just 2. 11 modulo 5 is 11 divided by 5. Remainder what? What is the remainder when you divide it? This is it. So that's basically how the this works. The operators and operands. Now I've been using print. I said print is a function, is more of like something in Python that if you put print and you put something in brackets, right, it's going to run that thing. So and give you the output of that thing. So if you do um let's say print and you put a text, a string inside, let's say I am very good with Python, very good with Python, and you run this, you'll see I am very good with Python. So that's what print does. It just gives you the output of it just outputs what you are doing and prints it out. So that's as simple as the word print. So if I say print 2 plus 2, now if I do 2 plus, my god, I should stop writing 2. So if I do 2, okay, let me do 2 plus 3. If I do 2 plus 3, I'll get 5. So you can see what this, I am very good with Python, is still running. So I'll comment it out, and I'm using control and right slash to comment very fast. So it's like a shortcut. So that's what I've been doing. So I can just comment. We did it in Excel, and sorry, in SQL. So 2 plus 3 is, I'll just comment this out so you can run this without interference. So 2 plus 3 is 5. You can see what is coming out. If I enclose this in a quote, a double quote, and I do this, I'm going to get 2 plus 3 as a string. So that's basically um um how the print works. Yes, so that's how the print basically works. I think I've explained this. So I don't know, do you have any questions? Any question on operators and operands, or something on print, the print statement, or you want to ask anything about have I okay I've not really okay I've explained data types too. I've not explained data structure yet, but from Python data type to operators and operands, do you have anything to say? Any questions?
These numbers on the left hand side in blue.
Oh, okay, this
What is
one's.
it? Yeah.
Oh, okay. So
In
what they mean is like the in is more of like tracking how I run them, and the number of times I run it. So when I started all of this in the beginning, it was starting from 1. So it's basically to keep track of what I'm doing and how many times I'm running. So currently now you can see there's 69 here, there's 50 here, there's 51, there's 73. If I want to interpret this now, I would say 50 was the, like, I ran the order in which I ran this currently was 50 first, 51, then I went to 69 and 73. So if I should start now again now, and I come in, you are saying 69. Sorry, hold on. Okay, so you are saying 69 here. So if I run this again now, you see 74. Because 73 here was the last thing I ran. 74 is here. If I run this again, I will have 75. If I come to this place and run it, it's now 76. Now, if I want to now start all over, all I have to do is interrupt the kernel. So this will stop running. everything. Then if I now start running again, of course it doesn't count this, right? It start counting from the actual. Oh, sorry, don't interrupt. Restart. Sorry, restart and clear output, or just restart. So it has started again. So definitely I'm supposed to run from here, but you can see now this is now empty. There's nothing there. That means I have not run it at all. So that's basically like what we use to identify in a situation where you have um a long how do I call it, a long notebook, a Jupyter notebook, right? How you can identify the ones you've run and the ones you've not run. So if I run this now, you can see one. It means I just started. The next one, 2, 3, 4. You can see how it's going, right? So you can also see there's outs. The reason why this one does not have outs because I'm using print. But if I just put math henry da 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 this plus yam, and it will solve this and give me the output. So it means that this output is as a result of this input. So I don't know if you understand, if that's clear enough. So yeah, so that's basically okay. Do you still have any questions on operators and Python data types before we move on? Because I'm going to spend a lot of time on the data structures. Okay, so I've talked about Python data types, integers. We are familiar with this. I've mentioned about the operators and operands. Now let's go to data structure. So, what is data structure? A data structure is basically like the structure of a data. So, what is data? Data is basically the simplest bit of information, right? According to definitions, terminologies. But in our situation, what is data? Data is anything that we assigned to a variable. I've talked about variables. So here we deal with variables, right? So in this situation now, if you look at this line, what is the data here? 1. 1 is a data, 2 is a data, 4 is a data. But it becomes a data when I assign it to something. So 1 here has been assigned to this. Now there's a structure that we now use for storing this data. Now this will now bring me to the example I like to use. I like to use bag. So we're going to start from lists. So talking about lists, what is a list? A list is more of, I say a list more of like a bag, a lady's bag. A lady's bag contains a lot of things, right? It contains makeup, contains eyeliner, contains a purse. What else does it contain? I don't know again. I'm out of, maybe okay, a book, a biro, and a pen. Yeah, I think I can use that. So a lady's bag contains those things. Now, all of these bags, all of the things are inside that bag currently. I think I should represent it here. So a bag, then the content of the bag is, sorry, I wrote B, bag. So the content of the bag is biro, pencil, eyeliner, so eyeliner, pencil, biro, purse, yes, a purse. What else? A book, let's say a book. So we have all of this inside a bag. Now we can also have another bag. Let's say this is a lady's bag. A lady's bag. Now we want to see a, and let's use my bag, Emmanuel's bag. Sorry. So Emmanuel's bag. So Emmanuel's bag in this situation, that's my bag. Let's say I have only biro inside. So I have red pen, I have blue pen, I have green pen, and I have yellow pen. Now there are two bags here, a lady's bag, a normal lady's bag, and my pen, my bag. Now, the lady's bag contained biro, pencil, eyeliner, purse, book. Now, can anybody see tell me the difference between Emmanuel's bag and the lady's bag? Like, can you see anything? Like, what can you see that is different in the bag? Or what makes both bags different? Any any identifiable thing that you are seeing? Can just highlight it. It doesn't have to be big. Just tell me what you are saying.
Maybe color.
Okay, color. Emmanuel's bag is just colors of pen. Why a lady's bag contains different things. So the things that are in Emmanuel's bag can be categorized. They are all the same thing, basically the same objects, pen, but in different what colors. For a lady's bag, you have other things like different kind of things. From biro, a biro is different from a pencil, it's different from an eyeliner, it's different from a purse, it's different from a book. So they are all complete different things. So this lady's bag now can contain different things. So in a list, a list is like a bag that can contain different kind of things, right? So rather than Emmanuel's bag that contains just pen, we have a lady's bag that contains different kind of things, from biro to pencil to eyeliner to purse to book. That's the way we have lists in Python too. A list contains of different kind of data types. So remember data type here: integers, float, string, boolean. So rather than having biro, so in a list you can say a list contains something like 1, 2, I should not be writing 2, 5.0, 5.35. This is this. A string is true. This is a string, or let me just say baggages. Then we have what else can I put? Okay, I can put a boolean. This is a boolean. So this is how a list looks like. Can contain different kind of things. But then how do we now identify a list? When you see a bag, for instance, an handbag, how do you know it's an handbag? The shape, the handle, the way it looks like, you can say, oh, this is an handbag. When you see a backpack, a backpack has two hands that you have to wear it and it stays in your bag, in your back, right? So how do we now identify a list in Python? So to identify a list, it's been enclosed in two a list is identified by just saying this. So this is how we identify a list, by using two square brackets. It has to be square. So anything that is enclosed in that square bracket, or a list, when you say a list, you see there is a list that is already enclosed in a square bracket. So in that square bracket, between the first one and between the opening bracket and the closing bracket, you have your different data types inside. So in this situation now, we have 1 to all of this inside this place. Why? So this has now become a list. So in Python, if you want to write a list, you have to open a square bracket, close it, and put all the things that you want to put inside. That's how you identify a list. So and you can actually now store this list inside a variable. Remember, a variable can be used to hold anything. A variable can be used to hold all of these things that you are saying here. It can be used to hold all of these data types that you are saying here. It basically means that I just want to, I use the example of myself, my name, me as a person, when I was given to being identified as Gbotemi, right? So that means that if they want to see this body of mine in a crowd of 20, all they have to do is call Gbotemi and I'm going to come out. Now, so it means that we can also assign, we can store this inside the variable. I think I didn't really mention assignment. How do we assign, right? How we store, that process of storing. So the process of storing is using equals to. So the normal equals to that you see that you use equals to normally, it is used for assignments. We call it assignments. So the way it works is what you want to assign. Sorry. So what you want to assign stays on. Sorry. The name of the variable you want to assign is on the left. Why what you want to assign is on the right. Value to be assigned. So the value to be assigned stays on the right. Why where you want to assign it stays on the left. So like this now, in a situation where I do something like 1 plus 1 equals to let me use the example. 1 plus 3 equals to Shegun. This is wrong. I'll get an error. Sorry, okay, it's even saying indent error. But this is actually wrong because it's saying that cannot assign expression here. So what I'm supposed to assign is, how I'm supposed to do it is say Shegun equals to what? 1 plus 3. Now, what has happened here is 1 plus 3 is now stored inside Shegun. That means that anywhere I call Shegun, what will come out? 4. I can tell that, okay, I want to put a string here and name that string Shegun. You can see this is capital, I put S here and I can see the difference. If I run this now and run this now, you see what will come out here. Shegun with a capital letter S. If I say it's Shegun 1.1.0, I want to put, all I have to do is what? Run it, call this again and Shegun 1. So you can see here now, all I needed to do was just change the input of this Shegun 1.0 or the input of this variable. All I need to do was just to be changing this thing. Shegun did not change. Sorry, this variable did not change. I didn't change it. I didn't have to rename it. All I had to do was just call it. So from running this line and this line, all I had to do was change this input, change whatever it is here, and calling Shegun here will return whatever I have assigned to small letter Shegun. I don't know if it's clear. So basically, that's how the assignments work. So equals to is called assignment variable. Sorry, assignment operator. So you know, when I was writing the operators, I had equals to, but I had to remove it. But now, so I can add it back. So equals to is called the assignment operator. So we use it for assigning things. So I can now successfully go back to this and add equals to. So it's called the assignment operator, and we use it for assigning things. So now we can now go back to what we're trying to do when we're talking about lists. That was saying you can now assign a list into a variable. So let's look at a list of things I bought in the market, right? So I call it so let me first write the list. So in the list I got tomato. In the market, sorry, I got tomato, I got red pepper. What else did I get? I got chicken. Okay, I bought chicken. Then let's say one more, turkey. So now this is a list. Can see turkey starts with capital letter T, chicken starts with capital letter C. This does not matter. What matters is it's all strings, right? Now if I run this now, I'm getting my list back. But if I want to store this list inside a variable, all I have to do is just say, let's say markets. Now if I call before I run this, right, I'm going to call markets here. If I run this now, can you see name error? It means that markets have not assigned anything to markets. Markets does not mean anything. Python, the way Python says this, you see it as nothing. Doesn't mean anything yet. Now if I run this and I put it in a string, in a quote, it is a string. I can call it, but if I don't put this, I cannot call it. So this market is different from is different from this market. So the difference between this market and this market is that this one is a what? A string, while this one is supposed to be a variable, though I've not assigned it yet. So if I run this now, right? Let me comment this and call markets now. Can you see I'll get the items I declared up here? So if I decide that okay, let's print it, right? We are using print. In fact, let's get used to using print. So I've printed it, I've printed market, I'm having this. Then I want to print the other thing, the other kind of market that's enclosed in a string. And I call this. You can see the first one has a list and the second one is just markets. So just to show you, I was telling you that you can use double quotes. It's just that if you're using double quote or single quotes, you have to be consistent. I can't start with double quotes, single quotes and end with double quotes. That's an error. Or I use double quotes here, a single quote here and use double quotes here. No, that's an error. So I have to use double quotes or single quotes. I have to be consistent anyways, that's the point.
Sorry, please go over it one more time.
Okay, the list, right?
Yes.
Okay.
From the market.
Oh, okay, no problem.
Yeah, the list. Yeah, the list.
So let me just start from lists. So I was saying a list is more of like, the way I say a list is more of like a bag of things, right, that contains several things, and anything can be inside. For us in Python, it means that we can have anything. You can have integers, you can have all your Python data types inside. You can even have your data structures, but you see more about that. Let's just limit it now to just the Python data types. So you can have integers, floats, boolean, and strings, right? Good. Now, how do you identify this? I mentioned that you use a square bracket. So it has to be a square. Where was I using? Okay, let me use here. So it has to be a square bracket, and this is a square bracket. Sorry, this is a square bracket. You open it, I think it's somewhere on the P lane. So all you have to do is just press up on the, I said P, the first row of your alphabets, not numbers, the first row of your alphabets, I think is consistent for everybody. The first row of your alphabets on the far right after your P, you see it there. So we use a square bracket to identify a list. So it's more of like the way you see a bag. When you see a bag can be empty, right? Don't forget, a bag can be empty and a bag can be filled with something. Now we can have an empty list in Python and we can try to have something inside. Now in this situation, what I just did here now is I have an empty list. So I'll just do new examples, fresh one. Examples are never. So now in this situation now, let's say school. So inside school now, school is a variable. I want to assign something to it, so I say list. So I want to assign a list of items. So I'll say pencil, book, like basically school materials, book, sorry, comma, close this comma, biro, what else? Uniform. So now this is a list. I can decide to not assign it to a variable actually. If I just leave it like this and I run this, I'm going to get another thing, the same list given back to me. Now, what I'm even doing, I'm putting strings. Let me mix this. Let me mix it with numbers 3, 4, 5. Let me put something in the middle here. Let me put true. Right? So let's stick with this first. So you can see it's coming out. Now, what I did now with the market is I actually assigned it to a variable. So I'm calling the variable here school. School equals to this. That means anywhere I call school, what will come out? This. So it's like I can carry the school around. So I'm just naming this. So it means I can carry the way I can carry my bag, my school bag around, right? And if I open it, I'll see the items. Is the way I can move this around and assign it to this and put all of this inside this variable, so that anywhere I need any of this, I can call what? School. So I'll just call school and all of this will come out. Now, I was saying that this is a variable. So where I was dealing with this example is that I was saying I was kind of giving the difference between variables, right? So normally I could just say if I call school like this and I put it around this and I put a quote around it, it is not the same thing as this school. What's the difference? This school here is a variable. This school here is a string. Why? Because it's already enclosed in a quote. This one was assigned. So interestingly, I can even add school to this. School as a string to this. So if I put enter and I come back and call this, you see school here. So it means that this school is identified as a string, this particular one that I put quotes, and this one that I've put here is a variable that has a list in it. So I've stored a list inside this school. So everywhere I call school, what will come out? This list of things that I have here. Sorry, hold on. Yes. So this list of things that I have here is what is going to come out anytime I call school. And this is a school as a string. Is it clear now? Like, do you get it? Alright, do you want to say something, Kingsley?
Can you hear me?
Yes, I can hear you. Although I know there's a background, but I can still hear you.
It's my son that is listening. Okay, the string cannot be assigned a variable.
No, a string,
Okay.
a string can be assigned to a variable. Anything can be assigned to a variable.
I'm saying, okay, now this school in the apostrophe, you can't make it, you can't add other variables to it.
No, because it's a string.
Okay.
Okay, so just to put more just to solidify that. So this school is a string. So data types cannot be a variable. You can't assign something to data types. Sorry, you can't assign something to data. 2 is 2. I can't assign something to 2. 3 is 3. I can't assign something to 3. 3 cannot be any other thing. It's a number. But here, school here is a string. I can't assign something to it. But if I don't enclose anything in it, for instance, if I want it as a variable, then that is possible. So that's why I was saying that this school here, if I call this school here, I will have this. If I put a quote around this, I'm going to have just school. So this one is a string. This one is a list or a bag. Where I say it looks like a bag. If by the time we are done, we should not be referring to as a bag again. A list is a list in Python, not a bag. But I had to use bag just to show you and make you understand how it works basically. Let me look at the time. It's almost time. Okay, so now I've explained how a list works now. No, not really, but I've explained what it looks like, and I used an example of a bag. Now, going back to that example of a bag now, there are things that you can do with that bag. Number one, you can remove an item, right? You can What are the other things you can do with a bag? You can insert an item into it. Sorry. You can insert an item into a bag, right? What else can you do? You can update an item. So when I mean update an item, you are replacing. So updating or replacing you are replacing an item. For instance, now in this situation where I have pencil, book, true biro, okay, for instance, in this market now, I can decide to remove tomato. That's me removing an item. So I'll be left with red pepper, chicken, and turkey. I can decide to insert another item into this. Let's say I saw something else. I saw butter. I can decide to add butter to this. So that means I'm inserting an item. Then I can also decide to what? Replace or update. So it means that I'm removing an item and I'm putting another item into it at that same position. So I'm sure some of us have seen a school bag before how it looks like. There are different positions. There's the front where we have some things, a front zip, a back zip, a middle zip, a side zip, different kind of pockets. Let me just call it pockets: the big pocket, a small pocket, a side pockets, right? Let's use an instance of a bag with 4 pockets: the one at the back, the big one at the back, the one at the front, then some bag have pocket at the side. So let's say right pocket and left pocket. So in that situation, we have we have big pockets, sorry, big pockets, we have small pockets, we have left pockets, and we have right pockets, right? Now in the situation where we have this, we have big pockets, we have small pockets, we have, sorry, pockets, not rockets, left pocket and right pocket. Now these are positions in the bag. Now I'm going to assign positions to this. So let's say big pocket is position 1, right? Small pocket is position 2. I should not be using 2. Okay. Left pocket is position 3. Then right pocket is position 4. Are we getting it? Are we following? So we have big pockets, we have small pockets, we have left pocket, and we have right pocket. So we have assigned positions to them because we want to easily identify the positions. Like we want to be able to put something. So now, looking at this tomato, red pepper item. Oh no, let me use this since we are dealing with something school. So let me use this. This is 4 items. So we have pencil, book, and true biro, right? Oh, sorry, this cannot be. This should be uniform. Let's say uniform. Uniform. So this item. So the way you see it now, let's say pencil is in big pockets, book is in what? Small pockets, uniform is in left pocket, and biro is in right pocket. So let's arrange it like that. Let's just see it like that. Now we can actually remove things. For instance, I can say I want to remove the pencil in position 1. If I remove the pencil, that means I'm removing it from position what? 1, right? If I remove the item, the number of items in the bag has reduced from 4 to what? 3. Now I've removed an item that way. If I'm inserting an item, I have to insert it into a particular position inside that bag, right? Now let's say I have an extra pocket. Let's just call it extra pockets, right? So extra pocket is what? 5. So I have an extra pocket. I can decide to put an extra thing inside that pocket and say, okay, I want to insert a textbook, right, into extra pocket. So if I want to put it, I have to be sure that, okay, I have to know the position that I want to insert that pocket, the textbook into extra pockets. Now we also have, I've mentioned about inserting. Now updating an item, that means I am removing and putting something there back. So I can take what else can I use? I've used biro. Have I used pen? No. So I can say pen. right? I want to take a pen. I want to take a pen from the biro position and put. I want to take the biro there and put pen there. Biro is in what position? Position what? 4. I want to put a pen there. That means I'm going to have to remove the biro and put pen. But remember that all these things I'm doing, I'm removing and inserting and updating, is easy or is possible because I know their positions. Now, I use that analogy because it's also similar to a list. So in a list, all of this you are saying, pencil, book, throw. Sorry, I have to redefine this. I should remove all of this. Sorry, hold on. I think okay. I should remove all of non-school items I have here. Okay, so it's now this. So I'm assigning school to it back. School equals to this. Good. So if I call school now, I have this good. So in the school item now, we have pencil, book, biro, and uniform. All of these are positions. They have positions. Now in Python or in programming language, you don't start counting from 0. You don't start counting from 1. You start counting from 0. So 0 is the first item, is the first number in the numeric or in the numerical in Python numerics, in programming numerics. So 0, so you start counting from 0. So you don't start counting from 1 actually. So it is actually like, let's say 0, 1, 2, right? I used to again. 2 dot dot dot, and so on and so forth. So you start counting from 0. Now, having known that you start counting from 0, the positions of all of this now, normally if I also ask you what is the position of this in the list, what would you say? Does anyone want to try? What's the position of pencil in this list? Anybody wants to try? Like, what's the position? Where is it? What's is it? The first position? Is it the second? Something like that. That's what I'm saying. Anybody?
The first.
Okay, good. It's the first item. So pencil here is the first, book here is the second, biro here is the third, uniform here is the fourth. Right. But if you now want to call it in Python, right? Of course, that's correct. That's not wrong. But in Python or in programming languages, if you want to refer to the first item, right, you refer it from 0. So you start counting from 0. So pencil, this is 2 years. So pencil is in position 0. So we call it index rather. So it's basically simple. Just switch position to index. So position is the same as index. So we call it index normally. Index, 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 index. So it's like saying what's the position of pencil in school. The position of pencil in school is position 0. So the position of book in school in this variable is position 1. The position of biro is position 2. Position of uniform is position 3. I don't know if you understand. So if I want to call pencil, if I want to, for instance, now if I want to see what is all the items, all I have to do is what? Do school, right? And everything comes out. Now, if I want just the first item, I said the first, I'll have to say position 0. School, sorry, I did that. So to do that, I would put school, the variable, then put a square bracket and the position of the item that I want to call, that I want to see. So if you want to see the item in position 3, I will put 3 because 3 is the last thing here, not 4. You have 0, 1, 2, sorry, we have 0, 1, 2, 3. So this is in position 3, index 3. This is in index what? 2. This is in index 1. This is in index 0. Normally it would have been 1, 2, 3, 4, but it's starting from 0. So the first one here is 0. Can see pencil. The second one is what? Book. So you go like that till you get to the end. So that's how to actually see. So that's just explaining that how to identify the positions of items in a list. So if I were to ask you now, how many items are in this list? Of course, it is 4. It's actually 4. There are 4 items in the list because it's not 3. 0 is still something. That's the difference in programming language. 0 means a lot. 0 is not nothing in Python. 0 means something. So 0 here is position 1. 1 is position 2. Sorry, what am I saying? 0 here is the first position. 1 is the second position. 2 is the is the second position. I think I'm already getting myself wrong. 2 is actually the third position. Yeah, 2 is the third position. 3 is the fourth position. So the fourth position in school is I have to call 3 to find it, because remember I start from 0. I start counting from 0, not 1. So school is in position 3, and there we have uniform. Is that okay? Let me see. So is that clear? Do we have questions? Any question? I think I'll just round up here. Because we still have quite a few things, and let me see. Okay. Yeah, I think we should just round up here and take a break. So sorry about that. So let me do a recap. So if you have questions, let's start preparing. So a recap for this, basically, so we started from identifying data structure, although we just mentioned this. Where we actually started from was from data types. So data types is, like I said, integers is whole number, floats is decimal numbers, strings are letters, and you identify a string by including it in a quote, a single quote or a double quote. Then we have boolean. How you identify a boolean is it just true or false? Is it true or false? That's just boolean. The boolean data type is divided into just two. Strings can be anything in a single quote or double quote. Floats remains anything that has decimals. Integers remains any number without what? Decimals. So it's like all numbers, right? Then we moved on to operators. That's operators and operands. That's we're talking about addition, your subtraction. We said division. We identify the difference between division and floor division. That floor division is just the whole number when you divide, while modulo is the remainder of your division. Division gives you your results in floats. Floor division and modulo gives your results in integer. And then we have multiplication, and we mentioned a bit about the assignment operator. So assignment operator, what you have, I think it's still here. It's still here. Okay, yeah, this is it. So where you have your variable and the value to be assigned. So you have the value to be assigned on your right, and you have the variable on your left. So what else? I think we went from there. Then we moved on to talking about variables, how variables work. So variable is like a single object that stores anything. It can store anything. It can store a number, it can store a float, it can store a list, it can store a tuple, it can store anything basically. So, and the variable have naming concepts, like how we name them, right? The things you can use to name them start from capital letter A to capital letter Z, or small letter A to small letter Z, or an underscore. So these are what you can use to start the name of your variable. Then along the line, you can have whatever thing you want to have inside, right? But you can't have operators inside your variables. You can't have it. Now, we went from variables, then we went to talk about lists. Oh, okay, we mentioned a bit about the print statement. So the print statement is just basically to output something. So I want to output, I want to see what is in this thing. I want to see the result of this thing. That's basically how a print works. And you write the print statement and you enclose it in a parenthesis. So parenthesis is basically um your parenthesis is parenthesis. So it's just basically I think to get your parenthesis you use shift and 9, that's to get the opening, and you use shift and 0 for the closing parenthesis. So it's more of like a curved brackets, a curved brackets. Yes, I call it curved. It's actually curved because we have curly brackets too. So we have three types of brackets. We have square brackets, we have curly brackets, like this curly, curly, and we have parentheses, which I refer to as curved brackets. So you already know when you open a bracket, any type of bracket, you have to close it, right? So then we moved on to lists, right? How a list work. A list is basically more of like a bag of items. It contains a lot. It can be empty, like I said, and it can not be empty. You can have things actually in it. And for Python or in programming language, the things that you can have inside a list are data types, any data types. It just have to be data. In our situation here, our data is all of this: integers, float, string, boolean, right? Let's just leave it at that. So you can have all of our data types inside a list, holding a list. And as you have a bag where you can remove items, put items into it, change the position of a particular item, remove a particular item and put another item in that same position, right? Know the number of items that are in a list. Know the number of items that are in a bag. For instance, you have, in our situation here, let's say we have 5 items inside the bag. 4 items inside the bag. So that way we know that there are 4 items inside the bag. And all those items have their respective positions called index in Python. So in Python, it is referred to as list. So you have all of these things. You can perform all of these operations. I can remove an item. I can place an item. So if I'm going to be using programming terms, I'll be calling it as I'm removing a variable, a data. I'm changing the data. I'm replacing a value. Okay, I can use value. I'm replacing the value. I'm updating a value. I'm inserting a value into the list, right? I can know the number of items that are inside a list, right? So those are some of the operations I'll be looking at when we continue in the next class, how to go about all of those things. So I think, yeah, that's it. So do we still have questions? Okay. All right, so I'll take it as there's no questions. I see digesting it. So one thing I'll do is I would rename this. So this is more of like class 1, and I should create a Google Drive link so I can start dropping this there. So this is our class 1. So I'll drop this so that we can try to go through it. Yeah, basically just go through it and run it on our respective system. I would advise that you probably have a clean one and try to practice the things that we have done, maybe single arithmetic, and even think of complex arithmetics, right, to do. So I think that's where we end the class, and